Very good morning, students. As usual, we can continue the topic of physics, that is system of particles and rotational motion. So the last time we have learned the moment of inertia of thin rod, uniform rod. Okay, then after that, that is circular ring. That circular ring, you have calculated the moment of inertia about the different axes. Today we can calculate the moment of inertia of circular disc. Okay, the ring and disc, you know what is the difference. Ring is hollow, disc having the surface area. Okay, so therefore here we have to consider the surface charge density. That was that time ring, we have to consider the that your linear density. Okay, here surface charge density sigma. So therefore, if you want to find out the moment of inertia of circular disc about different axes, so the first axis, now here the diagram looks like to be the same, but here this is the disc, and if I want to find out moment of inertia of a disc about an axis which is passing through its center but perpendicular to its plane, then at that time that moment of inertia can be calculated by using the formula mr square by 2. Okay, what is that first formula? Mr square by 2. Okay, so if this is the formula, then sir, what will be the radius of that gyration? For that case, so mm will get cancelled, r by root 2. Okay, so as usual you will calculate that answer. Next point, if I want to find out moment of inertia of circular disc about an axis. Okay, about an axis, but which axis? About its any diameter, about any diameter. Okay, so then how we can find out some moment of inertia? So this is the circular disc, and if I will consider, so this iz, this axis as iz, this axis as ix, and this axis as a iy. Okay, so here according to moment of inertia, means principle of parallel axis, IC or IO is equal to IC plus, or perpendicular axis theorem is telling IZ is equal to IX plus IY. And so here that is the 2 times ID, because Ix is equal to Iy is equal to ID. So therefore moment of inertia about its any diameter is equal to Iz by 2. And what is Iz? Mr square by 2 divided by 2, that is equal to mr square by 4. Okay, so that will be the moment of inertia about its any diameter. So naturally, what will be the radius of gyration? Kd is equal to mm will get cancelled, r by 2. Okay, so that will be the radius of gyration about its disc. Okay, r by 2. Next point, we want to calculate moment of inertia of disc tangent parallel to its plane, okay, tangent parallel to its plane means how this diagram will be. Suppose this is disc, this is the diameter, so that axis I will consider here. This is the tangent parallel to its plane. Okay, so this is IO, and if this is the radius, so then according to principle of parallel axis theorem, IO is equal to IC plus MH square. So IC will be here mr square by 4. Okay, plus m into r square. So that answer will be 5 mr square by 4. Okay, so that will be the your moment of inertia, tangent parallel to its plane. Now here in that case, because this IC which I have to consider about its diameter, so therefore mr square by 4 I have considered here. So what will be KO here? Okay, so if I want to find out KO here, so that answer will be mm will get cancelled, under root of 5 by 2 into r. Okay, because square root of r square will be r, square root of 4 will be 2, and that root 5 will be there. Okay, so that will be the tangent parallel to its plane. Next point, tangent perpendicular to its plane, tangent perpendicular to its plane. Okay, sir, how that moment of inertia will be there? So this is the disc, and if this is the tangent perpendicular to its plane, and I have to know the moment of inertia about its axis passing through its center perpendicular to its plane. I want to find out IO. This is again radius. Again, which theorem I can use? The parallel axis theorem. So therefore, IO is equal to IC plus MH square. Therefore, IC will be here in that case MR square by 2 plus M into R square. So therefore, your answer will be 3 by 2 mr square. So you have to learn all this moment of inertia by heart. So therefore KO is equal to root 3 by 2 times r. Okay, so that will be the moment of inertia tangent to its own plane. Root 3 by 2 times r. Okay, so these are the moment of inertia about the circular disc that we have calculated. Now we can proceed for the solid cylinder. Moment of inertia of solid cylinder, then hollow cylinder. Then after that we want to proceed for solid sphere and the hollow sphere. Okay, so these are the different diagrams. Now I can calculate moment of inertia of solid cylinder. Okay, so any wire can be considered as a cylinder, but here which I have considered here solid cylinder. Okay, so here in that case, if I will consider the moment of inertia of solid cylinder about its axis, but that axis is which is passing through axis of cylinder. Okay, so this is considered to be a passing through, means first axis of cylinder. Okay, then what will be moment of inertia? So now that moment of inertia, how we can calculate? If this, that means your cylinder is the solid cylinder. If you can consider like this, imagine this cylinder is a solid cylinder, like as this is the solid cylinder. Now if that cylinder is made up of number of discs, okay, and if I will take one of the disc, if I cut that one of the disc, then here in that case what will be the moment of inertia here in that case? So moment of inertia will be, that means about of the disc about an axis which is passing through the center and perpendicular to its length. Okay, perpendicular to its plane. So that answer will be mr square by 2. Okay, so therefore that first answer, so that IC is equal to mr square by 2. So therefore what will be the radius of gyration? So that mm will get cancelled, r by root 2. Okay, so that will be the first case. Now after that, once you calculated the axis of cylinder, then next point is about its transverse axis. Okay, sir, what will be the moment of inertia about its transverse axis? So what I will do now, I will take this axis which is passing through its center, perpendicular to its length of that cylinder, and this is the solid cylinder. Now here in that case, if I will take that disc, so here this answer will be that means line which is passing through its diameter. Okay, so that line will be passing through diameter, but here the same axis is passing through the center of that thin rod. Okay, means here this is the combination of two axes. So therefore moment of inertia will be, so about its, if you are considering the rod, then ml square by 12 plus about its disc passing through its any diameter, so that answer will be mr square by 4. So ml square by 12 plus mr square by 4, so that will be the moment of inertia. Okay, so sir, what will be the radius of gyration? So therefore Kc will be, mm will get cancelled. Okay, so under root of L square by 12 plus r square by 4. Okay, L square by 12 plus r square by 4. Don't take the square root of that thing, because this square root will not come out, because this is the plus sign. Then now you want to find out the third axis. Okay, moment of inertia of solid cylinder about, that means which axis you are talking about? Transverse axis passing through its one end. Transverse axis passing through its one end. Okay, so now that also you can calculate very easily. Okay, means which point he has given, you know these things, IC, and he is asking to you about this point. Okay, so here in that case that distance will be L. Okay, L by 2 we can consider. Okay, so now again here, so if you are calculating by using the principle of parallel axis theorem, IO is equal to IC plus mh square. So here IC will be ml square by 12 plus mr square by 4 plus m into h will be L by 2 means L square by 4. Okay. So here ml square by 12 plus ml square by 4, if I'll take here together, then your answer will becomes now. You see here ml square by 12 plus ml square by 4. If I'll take LCM as a 12, so 12 ones are 12, 4 3s are 12, 3 ml square plus 4 ml square, 1 ml square, 4 ml square by 12. 4 ml square by 12 means 4 3s are ml square by 3 plus mr square by 4. So that will be IO. Okay. Once you got that, your IO, so then what will be KO? So therefore that will be under root of ml square by 3 plus mr square by 4. So that will be moment of inertia of that solid cylinder about its transverse axis. Okay, so that will be, we can consider here in that case transverse axis will be ml square by 3 plus mr square by 4. Okay, and here if I will take m out, so therefore your answer will becomes only L square by 3 plus r square by 4. Okay, so once you got that things, again one more point you can calculate. So that means your, we suppose I want to find out tangent. Okay, about which axis? Tangent parallel to its length. Tangent parallel to its length. Okay, to its length means about this axis we are talking about. Okay, means this distance is supposed to be now here r. Okay, so can you tell me what will be the answer? Now that answer you have calculated, which one? That answer will be which one? mr square by 2. Okay, plus that will be mr square. So can you tell me what will be that answer? So that answer will be 3 by 2 mr square. And if this will be 3 by 2 mr square, so then that moment of inertia, okay, so that IO is equal to this. So therefore KO is equal to root 3 by 2 times R, because mm will get cancelled. Okay, so that will be the for solid cylinder. Now we can go for, so that is the hollow cylinder. Okay, instead of solid cylinder, if I consider it is the hollow cylinder. Okay, so now here in that case, for the that means your hollow cylinder, again the first point is about which one you are taking. First condition is about its any axis or axis of cylinder. Okay, about axis of cylinder. Now you can consider here in this case, so this is hollow cylinder. Now this is not a solid cylinder, this is the hollow cylinder, and if I want to find out that this axis, so then IC is equal to mr square. Okay, so that will be the mr square, because this is like as a ring, and moment of inertia about an axis which is passing through center perpendicular to its place, answer is mr square. Okay, and so therefore radius of gyration kc is equal to r only. And if second case, if I want to find out tangent parallel to its plane, okay, parallel to its plane, so that what will be its answer? Parallel to its length we can consider. So your answer will be, so this is the your cylinder, and if this is the length, so now here this is the axis, so here this is the r. So about this axis if I want to find out, so then your answer will be IO is equal to again IC plus mh square, and IC will be mr square plus mr square. Okay, so therefore your answer will be 2 mr square, and therefore your KO is equal to mm will get cancelled, 2 square root of 2 into r. Okay, so that is way how you have calculated for the ring. Next time we can see about the solid speed.